So whatever I thought, they are all the fundamentals to arrive to an very important point or the topic or the idea of today's class, that is Newton's first law of motion. There is a short explanation about Galileo's experiment and about his life in the book. Go to the book and read those things. I am not going to teach every minute things. So Galileo had an experiment and he expounded a very good result. After that, Newton have taken those results and he found three laws of motion. He said three laws of motion. Now, understanding the concept of friction, understanding the concept of balanced and unbalanced force, we arrive to this important point, that is Newton's first law of motion. Newton's first law of motion. What does it say? Newton's first law. It's very easy. Newton's first law says an object continues to be in the state of rest or of motion unless otherwise a force is applied to it. That force is an unbalanced force. This is first law of motion. Simple, damn easy. What is it? It says a body continues to be in the state of rest. If the body is like this for 1 day, 2 day, 3 day, for years, 100 years, 1000 years, this body will be in this state always. It continues to be in this state unless otherwise a force is applied to it. An external force, a force is compelled to apply on it. It will be for centuries and centuries, it will be in the state of rest. This is first law of motion. That's all. A body continues to be in the state of rest or in the state of motion. You see, it will be in the state of motion unless there is a force applied to stop it. There is a force on my hand that is stopping this. If if I don't have a hand, it will stop because there is frictional force on the ground that will stop. If there is no friction whatsoever, the ball will move on and on for years and years. There is no friction on the ball, there is no friction on the surface, it will move on and on. Nobody can stop it. So the body continues to be in the state of motion unless otherwise a force is applied to it. An external force is applied to stop it or change it. This force can be an external force like my hand or anything, or a natural force, a frictional force will stop it. So a force can only stop, a force can only move. So a body continues to be in the state of rest or state of motion unless otherwise an external force is applied to this body to stop it or to start it. This is first law of motion. That's all. Damn easy, very easy and very, very important form. Now, now, now we have done what is frictional force, I have said. Now I am going into some more deeper into that point. All objects resist a change in their state of motion. So, always they will resist to change. For example, if it is moving, it wants to move. It doesn't want to change. It offers some resistance. That I said that resistance is applied by the frictional force for the change of the state of motion. This tendency, because this there are okay. Now I will say what it is. The tendency of the undisturbed object to stay at rest or at motion, keep moving with the same velocity, is called inertia. This is very, very important concept. Inertia. Inertia. Inertia is, there are two types of inertia. One is inertia of rest and inertia of motion. Inertia is simply the laziness. Sometimes we used to have, no, the laziness. You sit and watch TV, and if you sit and play games, and your father or mother gives some work, go to the shop and buy milk, go to the shop and buy some grocery. You excuse, you show that inertia. What is that inertia? Don't want to move. You want to stay at the same place. You don't want to move. It is a laziness of the object, of you, of me, to move. If it is at the state of rest, it is the laziness to move. If it is the state of motion, it is the laziness to stop. It want to move. Nobody wants to stop this. This is called inertia. So Newton's, what I said, a body continues to be in the state of rest or of motion unless some unbalanced force is applied on it. Okay, what does it mean? The body wants to be at the same state. If it is at rest, it wants to be at rest. If it is in motion, it wants to be in motion. Nobody wants to stop it. Okay, it does not want to stop. There are very good example for this inertia. If you don't understand, I can give that very good examples that we see in our day-to-day life. Day-to-day life, that is inertia. Okay, you don't want to go somewhere to understand those concepts. Day-to-day life, you can see what is inertia. So it is a tendency of the body to be at the same state. If it is at rest. If it is at motion, at motion. That is called inertia. Now, I am getting into the examples to understand this. 4 examples I give, okay, of our day-to-day life to understand these concepts better. First example is you are traveling in a car. Okay, all of you might have traveled in a car, or even if you are traveling in a bike, the same applies. If you're moving at some speed, okay, now you are moving, your car or your bike is moving at some velocity and acceleration, and immediately you apply brake. What will you experience? The car or a bike is moving, but you are inside, you are also moving. But immediately when there is a brake applied, the vehicle is stopping, but your body is moving like this. Immediately with a sudden brake, what will you experience? You will experience some forward movement, right? Haven't you explained when you are on a car or a bike or a bus, immediately a sudden brake, come, you come in front. Why do you come? That is inertia. Why do you come? Because your body wants to be in the state of motion. Though the brake is applied for the bike, the brake is applied on the car or a bus, you want to move. Your body wants to move continuously. That is called inertia. So it is a resistance offered by the body to make that movement. Okay, that is one very good example. Now, another very good example is you are standing in a bus. So bus is at the bus stand. You are standing at the bus. You are standing in the bus. When the bus starts, immediately when he ignites and he applies the gear, when it starts. So it is at rest. Okay, when it start moving, it is another state. When it moving, what will you experience? You will experience some jerk, no? Why do you experience that? Because bus is at rest, so you want bus should be in the state of rest. You also want to be in state of rest. But when it moves, there is a change. So your body is resisting that change. Your legs are resisting that change. So you experience some jerk. That resistance is called inertia. Another example. You have fans. All of us have fans in our home. Um, for example, if you turn off a light, it will off on that second, right? It will off on that second. But if you turn off a fan, will you stop at that second? It will take some seconds, no? 10 seconds or 20 seconds to come to rest. What is that? That is inertia. Inertia means it continues to be in the state of motion, right? You turned off the fan. It continues to be in the state of motion. If there is no air resistance, it will run like that. But air is resisting and so it stops. It continues to be in the state of motion and the air resistance makes it and slowly it comes to stop. So the body wants to be in the state of motion. Another very good example I would say, if you might have gone to hill stations, Kodaikanal or Ooty, the bus will go and take turns like this, hairpin bends. When the bus take the right hand turn, you will all turn left. When the bus takes left hand turn, we all turn right. This is not this you can even experience in a long curve. If it is if your car or a bus taking a long curve, all will be pushed on the other side. Why is that? That is inertia. What is that inertia? That means your car is moving at one direction, one direction, but your body your body is not changing, but your body is changing its position because it could not resist that movement. Ultimately, you move on the other side. It is because you are resisting that motion on the other side. The car is taking right, but you are turning left. You cannot stop it. You cannot stop it because it is the inertia. It is the tendency of the object not to change. Not to change. It is a tendency of the object not to change its position, not to change its motion. So it will turn on the other side, it will turn on the other side. These are all the very, very good examples of inertia. Now, what is inertia? I have explained very well. I hope you understand inertia. So there is a resistance offered by the object to its state, whether it's a state of rest or state of motion. So resistance is the resistance offered to by the body, by the object to its state. So do all bodies have the same inertia? That is the question. All bodies have the same inertia? No, certainly not. It is very easy to move this duster. To move this duster, it's very easy to move this duster. But will that be very easy to move uh, a heavy box? No, this is easy. For example, an empty box is easy rather than a box full of books. Um, Moving a cart is easy than moving a train. Can you pull the train? You cannot pull the train, but you can move the cart. You can pull the vehicle. Okay. You can kick the ball. Okay. You can kick the ball. This is a rough ball, but you can kick the ball. Ball is very soft. Can you kick the stone? Will it move at the same distance? Now, both so different objects exerts different inertia. How that is different? This inertia is directly proportional to the mass of the object. That comes the first law of motion, mass. Directly proportional to the mass. So if there is heavy, if the mass is more heavy, if the mass is heavy, the inertia will be more. It offers greater resistance. If it is huge, If it's a huge bureau at your home and it is full of clothes and other things, you cannot move it because it exerts a more amount of inertia. So when the mass is high, it is easy to pull the cart, but it is not easy to pull the train. Train is very heavy. So inertia is directly proportional to the mass. So what is this inertia? F is equal to m into a. F is equal to m into a. Mass into acceleration due to gravity. This is the first law of motion. Inertia is a natural tendency of object to resist its change. So in this class, this would be a very long class today because I have classes once a week. Bear with me. I hope you understand, you enjoy all those classes what I am giving. Today we have discussed what is force, what is balanced and unbalanced force, what is frictional force, what is first law of motion and inertia. These things we have discussed. We have completed one small part of the second unit, and I have given you the code for the Google Classroom. I will give some assignments. I will follow it up. I will give the grades and marks based on the assignments. Assignments very easy. You can write it, take a photograph, and send to me. If you don't get my invitation, go and check your email. You have sent the emails, no? For that email, I have given the invitation for the Google Classroom. Remember, this is the code JMNQ7Q4. JMNQ7Q4. I will text you that code. You enter the code and enter into the physics classroom of class 9. There I will give some assignments. You do the assignment and take a photograph and send. I will give you the grade that will be taken as an internal marks. Sooner, by the end of next month, you will have a terminal exam also. This will carry 50 marks out of 100 marks. These internal marks will carry 50 marks out of 100 marks. The Google Forms, the assignments, all those carry 50 marks out of 100 marks that will be taken very seriously. Thanks for listening to me. Hope you understand. Hope you enjoy physics. More that you study, more you enjoy the subject, more you see the things and you understand physics and you enjoy physics. Okay, that is my ultimate aim. Thank you so much for today's class. Meet you in the next class. Bye. Take care.